Hello everyone and welcome. As AI becomes more advanced, we're moving beyond simple automation and entering the world of agentic systems. Today, AI agents can do much more than generate code. They can understand goals, create plans, make changes in repositories, open pull requests, and improve their work based on feedback. However, giving an agent more capabilities doesn't automatically make it reliable. To safely use agents in production environments, organizations must design clear architectures, define responsibilities, enforce governance, and maintain human oversight. In this session, we'll learn how to design reliable agent architectures in GitHub and integrate them into the Software Development Lifecycle, or SDLC. Mapping agent responsibilities across the SDLC. The first step is defining where agents can participate in the development lifecycle. Instead of allowing agents to work everywhere without restrictions, it's better to assign responsibilities to specific SDLC stages. The four major stages are planning. Here the agent can understand requirements, define scope, create plans, identify success criteria. Typical GitHub artifacts include issues, discussions, pull request descriptions, implementation. Here the agent can create branches, modify files, commit changes, open pull requests, validation. Here the system validates work through CI/CD checks, tests, security scans, workflow results, deployment. This is usually the most restricted stage. Deployments often require human approvals, environment controls, additional governance. A good principle is agents propose work, humans and policies approve work. Inputs, outputs, and success criteria. For an agent to work effectively, tasks must be clearly defined. Every task needs three things: inputs, information provided to the agent, requirements, issues, security alerts, constraints, allowed scope, outputs, what the agent produces, a structured plan, code changes, a pull request, supporting evidence, success criteria, how success is measured, tests pass, security issues are fixed, review requirements are met, scope remains within approved boundaries. Simply passing CI is not enough. Success should always match the actual business objective. For example, instead of saying, tests passed, the success criteria should be, vulnerability successfully resolved. Separating planning, execution, and validation. One of the most important architectural principles is separating planning, execution, validation. Planning defines what will be done, why it will be done, expected outcome. Execution performs code updates, branch creation, pull request generation. Validation confirms, checks pass, security requirements are met, reviews are completed. This separation improves visibility, reduces risk, and makes agent behavior easier to understand. 2 common agent workflows. Option 1. Plan first workflow. In this model, agent creates a plan. Reviewers approve the plan. Agent begins implementation only after approval. This is ideal for infrastructure changes, security-sensitive environments, production systems. Option 2. Plan and execute together. In this model, agent creates a plan. Agent immediately generates code changes. Both plan and code are reviewed together before merge. This approach is useful when speed is important, changes are low risk, teams are comfortable reviewing plan and implementation together. Regardless of the approach, approval is always required before merging. Pull requests as control points. In GitHub, pull requests are the central control mechanism. A typical agent workflow looks like this. Agent creates a branch. Agent opens a pull request. Required checks run. Code owners review changes. Approvals are completed. Pull request is merged. This ensures that agent-generated changes cannot bypass governance processes. Using governance controls. GitHub provides several controls for governing agent activities. Required checks. Ensure. Builds pass. Tests succeed. Security scans complete. Code owners. Automatically route changes to the correct reviewers. Examples. Security team reviews security folders. Platform team reviews workflow files. Branch protection and rule sets. Prevent unsafe merges. Direct commits to protected branches. Environment approvals. Required before. Deployments. Accessing protected secrets. Production execution. These controls help organizations maintain quality and compliance. Risk-based autonomy. Not every task requires the same level of automation. Organizations should apply different levels of autonomy based on risk. Low-risk tasks. Examples: documentation updates, formatting fixes. These can often be automated. Medium-risk tasks. Examples: application code changes, dependency updates. Require pull requests, checks, reviews. High-risk tasks. Examples: infrastructure updates, workflow modifications. Require code owner's approval, additional reviews, stricter controls. Critical tasks. Examples: production deployments, secret management. Agents can prepare changes, but humans must approve execution. Building reliable workflows. Reliable workflows require structured communication between jobs and processes. Best practices include: use outputs. Pass information between workflow steps and jobs in a structured way. Use context. Leverage GitHub context information for intelligent workflow decisions. Safe triggers. Ensure workflows execute only in approved situations. For example, pull request validation should only run for pull request events. Deployment jobs should only run after approvals. The goal is to prevent unintended execution. Observability and evidence. Every agent action should generate evidence. A reliable system should always produce clear plan, pull requests, commit history, workflow runs, test results, security scan reports, review outcomes. This creates a complete audit trail. If a problem occurs later, teams can understand what happened, why it happened, who approved it, which evidence supported the decision. Managing tools, secrets, and MCP integrations. Agent tools should be carefully controlled. Tool governance. Allow agents to use only approved tools. Prefer allow lists instead of unrestricted access. MCP integrations. When using external systems, limit available capabilities. Review integrations carefully. Treat new tools as high-risk additions. Secret management. Never store secrets in source code, workflow files, configuration files. Instead, use GitHub secrets. Apply environment restrictions. Follow least privilege principles. Hooks and guardrails. Hooks provide another layer of protection. They can block unsafe operations, validate actions before execution, create audit logs, trigger alerts when policies are violated. Examples include pre-action hooks, check actions before execution, post-action hooks, record activity for auditing, error hooks, capture failures and initiate escalation. Hooks help enforce rules independently of the AI model itself. Reliability through human oversight. Even the best AI agents will occasionally fail. That's why reliable architectures include retries, allow agents to fix temporary issues, escalation, transfer unresolved problems to humans, rollback plans, provide recovery paths for high-risk changes, least privilege, grant only the permissions necessary to perform a task. This minimizes risk and limits the impact of mistakes. Summary. Let's recap the key points. In this module, we learned how to design reliable agentic AI architectures within GitHub. We covered mapping agent responsibilities across SDLC stages, defining clear inputs, outputs, and success criteria, separating planning, execution, and validation, using pull requests as governance and control points, applying code owners, rule sets, environment approvals, and required checks, implementing risk-based autonomy, building reliable workflows using outputs, contexts, and safe triggers, maintaining observability through logs, artifacts, and audit trails, safely managing tools, MCP integrations, and secrets, using hooks, escalation paths, and least privilege access to improve reliability. The key takeaway is simple. Agentic systems should increase productivity, But governance, transparency, validation, and human oversight must always remain in place. Thank you, and let's continue exploring advanced GitHub agentic AI capabilities in the next session.